Good afternoon, everyone. Welcome to my presentation. My name is GANA. I'm based in Germany. I'm a consultant working for Capgemini Engineering, as well as being a fellow of the PP6 Forum. As consultant, I support operators. I'm mainly a consultant, senior consultant for Vodafone, but I'm also supporting other operators within Europe and also across the globe, particularly on the topic of network automation as well as standardization, working together with Vodafone within the ETSI activities on standardization for network automation, together with the other operators, Orange and Verizon. We are working together in this space of knowledge plane driven networking, the era we have just tapped into. So my presentation is going to focus on end-to-end federated GANA knowledge planes for AI-powered closed-loop self-adaptive security management and control across 5G network slices. The paradigm itself that we are addressing with the GANA framework generic autonomic networking architecture is what we call the autonomic management and control paradigm, the AMC, which has now been adopted in many SDOs. This paradigm that we started in ETSI, AFI, the Autonomic Future Internet Working Group within the INT. So my colleagues here in this presentation is Tayeb Ben Mariam from Orange, Muslim El Kotob from Vodafone, Benoit from Orange, and Said Sohi. The work itself started as a proof of concept. We have been working on a proof of concept on answering the question of what is the gap within standardization with respect to autonomic security management and control, which is closed-loop security management and control for 5G network slices and networks and services. So we built a proof of concept together with a number of operators as well as a vendor, leading vendor within the security solutions delivering the industry. And within this proof of concept, we started to look at what are the activities, what are the steps we need towards standardization of a generic framework for multi-domain federated Hexagonal knowledge planes for end-to-end autonomic security management and control for 5G slices, networks, and services. So within this space, we have launched a work item. ETSI has now launched a work item on this based on the success of the proof of concept that we have been driving around this topic. The proof of concept is accessible on that URL that you see here, and you're welcome to join in the activities of the proof of concept for this generic framework we are building, answering the question of how to automate intelligently security management and control end-to-end across 5G network domains, as well as slices. Contributors to talk, I will not go through all of these. It's a number of contributors from the operators and vendors that contributed to this, and would like to appreciate their contribution to the proof of concept that we ran, that was then that triggered then the activity of standardizing the framework we have been working on and demonstrating in the proof of concept. Key messages and reflections around the need for autonomic security management and control in 5G. We know there are so many problems with respect to security, especially for 5G. It brings a lot of challenges, and some of the challenges that we see, even in the let's say security risks and attacks landscape within 5G, they require automated security policing, dynamic security policing in the network, and that would bring, let's say, the intelligence as well as the benefit of removing the human in the loop in managing the security of the network. The autonomics is the answer to that. And there is a white paper that we have published that documents all the different challenges of security in 5G that can be addressed through automated or autonomic dynamic security management and control within the 5G. So the URL for the white paper is given below, and you can download the white paper from that URL. Agenda of my presentation. I start with the ETSI GANA framework for multi-layer autonomics, and then talk about the integration of the ETSI GANA knowledge plane platform with the SDN and NFV and other type of management and control systems. So there's a very important concept that we have introduced, which is called the knowledge plane. It's a platform. We are into the era of knowledge plane driven networking for autonomous networks. And we would like to illustrate that as well, to give a picture to some of you that may not know about the GANA framework and knowledge plane driven networking. I'll then move into the generic framework for multi-domain federated GANA knowledge planes for end-to-end autonomic security management and control for 5G network slices and services. The framework itself, the generic framework, I'll present that, and then talk about this work item and the invite to join and contribute to the work item. I will briefly touch on the capabilities of Checkpoint, which is the vendor that we worked with in the proof of concept in terms of the security functions that enable the industry to implement the framework, as we demonstrated in the POC proof of concept in line with the Hexagonal framework. In particular, looking at how the Checkpoint security management platform called AT can be used. This is one that we focus on in the proof of concept, how it can be used to implement the GANA security KP knowledge plane security management DEs. The demo itself was focusing on autonomic security assurance for differentiated service SLAs, 5G slices, while applying what we are calling the security as a service model for telcos. It's quite an interesting concept that we're talking about here for telcos, which is security as a service in 5G. The POC, the consortium, has a number of vendors and operators, and you can join. You can check on the website and take a look at and how to join the proof of concept consortium itself. So now let's delve into the Hexagonal multi-layer autonomics and the integration of the Hexagonal knowledge plane with other systems such as orchestrators, SDN controllers, manual stakes, and SOLAS, OSS, and PSS, and configuration management systems. The GANA itself is what we call a holistic and unifying model for AMC, autonomic management and control, which is about control loops, nesting of control loops, hierarchical control loops, part of the framework, as we illustrate within the GANA framework. The background is that this model has been developed based on best practices and different models. Some of you are familiar with the IBM MAPE model. There's also the OODA for car knowledge plane, which is a concept that emerged from MIT, knowledge plane networking. And that's a very important concept that then the GANA standardized in terms of the functional blocks that constitute a knowledge plane. There's been work from the European Commission research projects from FP7 through to Horizon that contributed in the development of the GANA framework as a unifying model, unifying in the sense that it captures the holistic nature or picture regarding the abstraction levels at which to introduce the autonomics and multi-layer autonomics, the control groups. From the US, NSF funded projects such as the 4D architecture contributed, and other initiatives contributed. They were considered in then specifying, developing the GANA framework. And here it comes, the generic autonomic networking architecture framework. And we start looking at a network element like a router and a switch. And within the network elements, we expect to have fast reaction by control loops that operate in fast timescales in terms of reaction. And the structure of a network element, as you see it, at the bottom we have protocol stacks, or what we call the resource layer, which constitute the managed entities. So we have protocols with protocol stacks that constitute the managed entities within the network element, and we create an overlay of abstraction on top of the resources layer to create what we call the DEs, the decision elements, which are software modules that then drive the control loop over specifically assigned managed entities. So for example, QoS is controlling resources pertaining to provisioning QoS within the node, and in collaboration with other DEs for QoS that are within the network to implement an end-to-end global policy on QoS provisioning and monitoring and adaptive control of the QoS mechanisms. Within the node, we have a superior DE that we call the node main decision element, which implements the superior functions like security, policing security for the node, as well as resilience and survivability, fault management, auto configuration, and auto discovery, enabling the element to discover information, as well as discover other entities that need to be networked with the element. In terms of AI, we see that GANA defined this, particularly the 4 levels at which to introduce control loops, but primarily it recommends to focus on the levels 2, 3, and 4, going upwards into the plane we call the knowledge plane. It forms a platform. This is the plane where the DEs that operate in slow control loops are supposed to be implemented within the platform. So we see QoS management DE, we see fault management DE, routing management DE. These are some of the DEs that need to be implemented within the level of the network level. We call them the knowledge plane, which has the scope of the whole network in terms of having views of the network and how the policy control the network elements under the responsibility of the knowledge plane. In terms of complexity of AI algorithms, they need to increase from fast control loops up into the knowledge plane. They are getting more and more complex. So we start with, we may have zero cognitive algorithms within the fast control loops within the network element. But at level 3, we may have some moderate type of cognitive AI algorithms. But the more complex, we expect them to be within the knowledge plane that has a lot of data processing, a lot of time scaling in operating the slow control loops, but policy controlling and refining the behavior of the network and programming the network. So the complexity of AI is increasing, and the degree of cognition is increasing from the network element up into the knowledge plane, which is the full-blown cognitive platform for the network. Functional blocks are defined within the specification at the TS 103192, which is the standard for the Hexagonal framework. What also the specification provides is that it provides a mapping between the autonomic functions, which we are calling the DEs. For example, the mobility monitoring management decision element is supposed to be associated with the monitoring protocols and mechanisms and tools of the network element, especially when you're looking at the monitoring DE within the network element. It has to orchestrate monitoring functions. It has to tune the monitoring functions intelligently based on the demand for monitoring, right? So the monitoring itself is supposed to be elastic in autonomic networks and autonomous networks as we move into the future. Same applies to other DEs. So there's a table that is provided that gives a guidance to the DE implementers that implement control loops over managed entities. So the DEs mapped to the MEs, and so the DE can then implement the specific control loops over the managed entities. So the different types of DEs, they have mappings to their corresponding managed entities. So this is a guide table that is provided within the TS, the technical specification. So that gives the guides to the implementers and innovators of DEs and algorithms. In terms of looking at the multi-layer autonomics, we talked about the knowledge plane, we talked about fast control loops or autonomic functions like the DEs that we talked about that need to be implemented within the infrastructure to implement distributed algorithms within the infrastructure. So there are some algorithms that are better done within the infrastructure itself, and algorithms are better done centrally in a logical centralized plane. So the hybrid zone, for example, is a typical illustration of how the GANA is implemented for the run, because it combines D zone within the E node Bs, and then the C zone that is policy controlling the D zone. So that's a mapping between the GANA and the hybrid zone to give a picture of how this the model, the GANA model is implemented for run. For other network segments, the GANA is applicable to all other network segments, and we are talking about the GANA for the backhaul, transport, and core network, and we have DEs, the autonomic functions modules within the low-level autonomics that can be implemented within the network infrastructure. So we see fast control loops, they are controlled by the slow control loops. Slow control loops, the policy control the fast control loops. Fast control loops bring a lot of benefits in terms of local reaction, which does not need intervention of the knowledge plane, right? So that's very important to understand. Let's come to the picture itself of the knowledge plane concept, how it looks like, the space, the room that is occupied by the knowledge plane platform concept. So we see that the knowledge plane is supposed to be the brain of the network that is supposed to consume events from different through different systems like OSSs and MANO, as well as service orchestrators, as well as SDN controllers, and of course the network infrastructure itself, EMSs. They are supposed to supply information in form of events to the knowledge plane that forms then the brain of the network that programs the network, is reasoning over events through the various interfaces it can consume the events depending on the environment in which the knowledge plane is implemented. And at the same time, the northbound interfaces of these systems also provide for the knowledge plane to program the network, to change the network via the OSS or via the orchestrator. The knowledge plane may decide that based on some failures in the network or attacks in the network, the knowledge plane can reorchestrate certain backup paths, backup services within the network, and that it can selectively do that via the OSS, or certain problems can be remediated directly via the SDN controller. So that's what the knowledge plane is about. Also, in terms of, let's say, what 3GPP is doing, the analytics functions, they are supposed to be orchestrated. They can be orchestrated by the knowledge plane. At the same time, they offer services to the knowledge plane. So that's how we see the knowledge plane also interfacing with ticketing systems for clearance of tickets and the like. So that's the concept that the GANA is bringing in terms of the knowledge plane, so that we talk about the knowledge plane driven networking as we move into the future for autonomics. Now let's come to the generic framework for multi-domain federated Hexagonal knowledge planes for end-to-end autonomic security management and control for 5G slices, networks, and services. There's a white paper we have published on that. This was the basis of the proof of concept. It's downloadable from that URL that you see here. So multi-domain security management and control, very important topic for 5G networks and slices. If we look at the aspect of autonomic security management and control, we are focusing on the DEs for security, right? And that's very important to see what we have highlighted here. If we look at network elements, there are certain network elements, or if we talk about zero trust, we could say even every network element may have a need to have a security management DE embedded, which can orchestrate services for security within the node, as well as being policy controlled by the network level security management DE within the knowledge plane platform, the outer knowledge plane platform. So that's the picture that we see in terms of the security focus when it comes to DEs. The DE for security is dynamically orchestrating different type of security mechanisms within the protocol stacks, and as well as services, applications that can be hosted by the element in terms of providing security as a service, or in terms of providing security mechanisms that the security DE for the network element can enforce to protect the network element from attacks and from other type of risks for the network element. And mapping in terms of security as a service, this is something that we have discussed in this framework, security as a service enablers, talking about if we map to the protocol stacks, we're talking about protocols that may have intrinsic security, but at the same time they need to form also libraries in terms of mechanisms of and protocols that can be employed by the network element, the security management DE for the network element to orchestrate the services and the applications. On the network level, we also have the mapping of security applications and services library that can be that need to be orchestrated depending on the context, like encryption as a service. That's one of the examples. Now, looking at the knowledge plane itself, within the framework, we are now standardizing. We are talking about the security management DE in particular, but of course, as the knowledge plane has other DEs like QS, resilience, mobility management DE. The most important thing about GANA is that it differentiates from any other framework is that it defines the atomic autonomic functions, the DEs, and mapping to the managed entities, and then has a framework also of policy control and conflict resolutions in terms of stability of control loops and like what we don't find in any other frameworks we hear in the industry as well as in literature. Now, looking at the knowledge plane, we have the security management DE in the knowledge plane, complex event processing, cognition, AI-driven security management, and here this is how we see the DE programming the network security functions like gateways and IPS and the like, either through a translation service that translates between the language that the function is, security function is, speaks in terms of management and control, versus a unified data model and language that can be used by by the DEs to talk to the infrastructure, which actually simplifies the programmability, because a unified language can be used by the DEs and is translated by a translation function from towards the infrastructure. There could be some plugins like we have seen with the SDN controllers on the southbound in terms of then the plugins that talk to the infrastructure, but we need a language, a unified language that can be used by the knowledge plane to program the infrastructure elements. And we could have, as an option, a bypass of this translation function, but there are benefits of using a translation function rather than having the DEs talk the actual language that the network functions like gateways speak in terms of management and control. That makes it complex when we don't have a translation function in between. But these are options that can be followed. So it's part of the framework that we are prescribing to also talk about those kind of options we have. Now, let's look at Federation of GANA KPs, knowledge planes for end-to-end autonomic service and security assurance for 5G network devices. We're looking at then horizontal federation. We have a knowledge plane for domain A, which is the access network. And we are seeing at the bottom, we have the fast control loops within the infrastructure. These are correspondingly implemented by the DEs, the level 3 DEs, GANA level 3 DEs. When we are talking about the run, the CSON itself is mapping to a GANA knowledge plane for the run. What sort of security functions we are talking about in terms of autonomics? We're talking about self-protection and self-defense. That means that this particular silo has to implement self-defense and self-protection, but at the same time, there are certain problems that may begin or emanate from certain segments or are detected within certain network segments like the transport or the core network that need to be shared as events, such that the knowledge planes can collaborate on how to actually protect the network, at the same time deliver services that bypasses a certain security risk or problem. So that's why we need federation between the knowledge planes to implement end-to-end security management and control, end-to-end self-protection and self-defense by the DEs within the corresponding knowledge planes for these corresponding domains. In terms of federation, another option is vertical federation, which is hierarchical federation of KPs. As we can see, it's also described in the paper, and we are describing in the framework we are now standardizing in ETSI. Looking at one particular DE knowledge plane, the DEs within that particular knowledge plane, for example, for the core network, we are talking about then the DEs coordinating with each other to deliver autonomic management and control objectives. So we are talking about the security DE collaborating with other DEs like fault management, QS, as well as forwarding management for within that the knowledge plane platform to deliver on the objective of the network. So, for example, you may have security-driven QS management, in which security management DE is communicating with the QS DE in terms of the risks and predictions of risks, so that the QS can provision certain backup paths in the network that bypass certain areas or pockets of the network that have high risks as detected, as the security management DE can then resolve the problems and apply policies, and then that dynamicity of shifting traffic towards, let's say, paths that do not have security risks. Those are the coordinations of the autonomic functions that need to be achieved through the federation or the DE to DE communication. And one of the points that one of the functional blocks of the GANA knowledge plane is what is called the ONIX overlay network for information exchange real time, which is a federation of information servers providing publish subscribe to discover information, to discover context and the like. And one of the repositories is the real-time inventory for detected security attacks, threats and risks, and history of attacks and impacts on services, and the land risks and trust models and the like. So this repository is part of a federation with other information servers of the ONIX system as a knowledge base for the autonomic network. Algorithms run on each of the servers to create the web of knowledge by correlation and building the relationship between different entities within the different repositories. So we need the algorithms to run on this platform. So that's the ONIX itself. It's part of the Hexagonal framework, and we are looking at federation between, let's say, information servers between two different domains, like between two different operators. That's something we have done, and I'll show you briefly on a demo that we did. In terms of implementation strategies for DEs, you see the MAPE model can be applied to implement the security management DE for closed loop management and control, down the managed entities, security gateways and the like. The paper describes that, and looking at also the role of correlation of the security DE in open and closed loop autonomic security management and control, interfacing with different types of functions as data sources. That's very important. Also data lakes and the like, and of course, as we said, knowledge plane being the encapsulation of the security DE. Other DEs within the knowledge plane also need to interface with orchestrators and SDN controllers. More details are described in the white paper that you see in the URL. Ticketing systems, we talked about the need for the security to also interface with ticketing systems. That's also described in the white paper, but it will be part of the framework that we are standardizing. And so we encourage you to take a look at the work that we are doing in this work item. There's this URL that you see here. So we are saying, come join this activity we are doing on standardizing this generic framework that delivers end-to-end self-protection and self-defense for 5G networks via the knowledge plane for the access, for the run, knowledge plane for example, and knowledge plane for the transport networks, and knowledge plane for the core network. And they federate, they exchange state information, they coordinate in terms of how to enforce end-to-end security management and control. So you are invited to join the work that we are doing. Coming to the part of the proof of concept we did with checkpoint capabilities, we looked at, you'll find this in the white paper as well, of the components of checkpoint that we focused on in terms of answering the question of how a security DE for a particular network segment can be implemented. We were looking at the threat cloud and also for the real-time repository for detected security attacks and risks and the like. We focused on the threat cloud as well. It provides a component to implement this real-time repository. More details you can find in the white paper. Coming to the subject of federation again, where we were talking about knowledge planes, and then the security functions of checkpoint for the MEC cloud, for the different functions for the core network that can be programmed by the corresponding knowledge planes, which then effect, of course, like we said, end-to-end self-protection and self-defense for different types of attacks for the 5G network. Security perimeters here, platforms that can also be programmed by the knowledge planes. You'll find a lot of details in the white paper. Same applies to a very interesting aspect of looking at the KP, knowledge plane security management DE, the stroke control loop DE, and of course the attack and threat detection and prediction modules that are part of the DE. They are integral part of the DE, or a DE in the gateway, in the security gateway, and a DE in the knowledge plane level, and this outer loop. And talking about dissemination of the detected attacks or predicted attacks, thanks to the AI within the DE, as how it is then propagated into the real-time repository, and the interworking of the upper DE, security DE in the knowledge plane, and the security DE, management DE in the gateway. This we demonstrated, and then we looked at federation as well in terms of information across different domains, in terms of threats, in terms of attack signatures and the like, and I'll show briefly what we did with Orange and Vodafone. Here, the platform that we've checkpoint we found interesting, of course, per silo knowledge plane, we could see security management DE for the MEC cloud, for the transport, for the core network, and how it interfaces via an IP-based API with other DEs of the corresponding of the same knowledge plane. So knowledge plane for MEC, knowledge plane for transport, knowledge plane for core, all these sets of DEs, how they coordinate with each other via the microservices bus we talked about in terms of implementation. Demo part that we did also was interesting to look at autonomic security assurance for differentiated security SLAs for 5G slices, while applying security as a service model, different classes of protection of services in terms of slices in the 5G, and how those slices can be assured by way of knowledge planes programming the different security functions of the network. So we have vertical segmentation for security as a service. We have also horizontal segmentation, security as a service. They are also described in the white paper. They are also being described more in detail in this standardized framework, the generic framework we are talking about. We had a very good, interesting demo that looked at a detected security risk in terms of an EMBB slice user who is downloading some files, and there are some detected security problems, and then the hashing of the security attack is then being shared between Orange and Vodafone. It was detected in Orange, and then it is being shared to Vodafone, so that the knowledge planes on the side of Vodafone can then proactively compute actions to remediate, to protect the network, thanks to the sharing of the security attack and the hash that was detected initially in Orange and then disseminated through Federation of Knowledge Planes into the knowledge planes in Vodafone networks. So that's very interesting. And we are saying that we are inviting you to join this activity on what we are standardizing as a generic framework that I've just illustrated in terms of knowledge planes. They can be supplied by anyone. That's the genericity part of that generic framework for security management and control. And we invite you to join this work item. You read more details about this work item on this URL, and we invite you to join. With that, we would like to thank you so much as we work on this journey on working on autonomic security management and control, which is really dynamic policing of security, dynamic programming of security for self-protection and self-defense of the network. This is what is lacking in 5G, and the autonomics is going to bring the value thanks to the knowledge planes, the decision elements of security. They collaborate with other TEs for QoS, for mobility management to deliver best on objectives for the autonomic network. With that, I would like to thank you. Thank you so much.